Okay, this video we're looking at Unit 10B, solving or problem solving with geometry. And so when we looked at Unit 10A, we surveyed geometrical properties of 2- and 3-dimensional objects. In this unit, we're going to investigate additional geometric ideas that can be used to solve a lot of different practical problems. So the first thing we're going to look at is the concept of latitude and longitude. And this is how it's a common way that we measure position on the Earth. So latitude measures your position north or south of the equator. So the equator is defined to have a latitude of 0 degrees, and then locations in the northern hemisphere. So north of the equator. So for us in the United States, we have we are in the north part. That's why we say the northern hemisphere, because we are north of the equator. The southern hemisphere is denoted by S for the south. And the North Pole is the maximum latitude of 90 degrees north, and the South Pole is the maximum latitude 90 degrees south. And if you look at the lines of latitude, they're actually circles that run parallel to the equator. So you have, here's a circle of 60 degrees north, and then 30 degrees north, and those all run parallel to the equator. Okay, and then you can see in here there's some random places. They've picked Miami, Buenos Aires, Rome. They give you the longitude and the latitude and longitude coordinates of those. Longitude is just measuring east to west. Sometimes these are also called, you'll hear them called Meridians of Longitude. These are semicircles that extend from the North Pole to the South Pole. And Greenwich, England is defined to have a longitude of 0 degrees and is called the prime meridian. You can look up a little history on that if you'd like to. But longitude, they are angles less than or equal to 180 degrees. So a location less than halfway around the world to the east of the prime meridian will be designated east, and a location that is west will have west. And again, they won't exceed 180 degrees. So you won't have like 189 degrees east that actually pull you into the western side once you eclipse that point of 180 degrees, because then that means it would be shorter to go out to the west than it would be going to the east. And so that's why you have a distinction there. Okay, and then that figure gives you some latitude and longitudinal coordinates for a few different cities. So a couple questions to answer about latitude and longitude. First, find the latitude and longitude of Madrid, Spain. I actually spent 2 years in Madrid, Spain, so I thought this question was pretty awesome to put in there. This is not something you need to have memorized or that you should know off the top of your head. A couple of things you should know is that this thing is definitely going to be in the northern hemisphere, and then you may or may not know as far as its setting in reference to that 0 degree, that longitude of 0 degree, the prime meridian, because it's actually pretty close. We should know that the east or west on that's going to be small, but if you look this up on Google or some other location, it's about 40 degrees north and then 4 degrees west. So it's in the northern hemisphere, up 40 degrees from the equator, and then it's 4 degrees to the west of Greenwich, England. So that's just quick ways to find those. You just Google latitude and longitude coordinates of Madrid, Spain, and you should be able to get those quickly. Now, if you want to find the latitude and longitude of the location on the Earth that's precisely opposite to a location such as Portland, Oregon, here's how you would do that. If you want to go opposite with your latitude, if it's 46 degrees north, perfectly opposite of that is just going 46 degrees south. That'll take you perfectly opposite of that. So the latitude is quite easy. But the longitude, so if you're at 123 degrees west, then if you go opposite that, you're going to be east. But what you need to do is you need to take 180 degrees and subtract the 123 degrees west. So the opposite, exact opposite, would be 46 degrees south, and this is going to be 57 degrees east. And that would be on the exact opposite side of the world of Portland, Oregon. Okay, and the next, which is further from the South Pole. So remember, the South Pole is 90 degrees south. Guatemala City, Guatemala, or Lusaka, Zambia. If you look at these, Guatemala City, so I'll call that GC for Guatemala City, is 15 degrees north, 91 degrees west. And then Lusaka, Zambia is going to be at actually 15 degrees south, 28 degrees west. And again, you can look these up on Google. In your homework, this information is going to be given to you. You are not expected to know these directly. But then, but you are going to need to be able to determine, okay, based off of this information, which one's closer to the South Pole. And again, the South Pole is at 90 degrees south. So in this case, or excuse me, this one says which one is farther from, and Guatemala City is farther because it's 15 degrees north. So you'd have to go down 15 degrees to get to 0 degrees, which is the equator, and then the full 90. Whereas Lusaka is already in the southern hemisphere, so it doesn't take as long to get there. Okay, but that's a little bit about latitude and longitude, and there are a lot of applications in these. We won't really dive too deep into these, but it's just good to know some of the applications there. Okay, next we're going to be looking at, again, we try and find ways to apply geometry. Use of angles. So there are many geometric problems requiring the work with angles. For example, we use angles in navigation, which we talked about longitude and latitude and other things there. Architectural design for measuring steepness of mountains, orientations of roads. In 10A, we were working with measurement in degrees, which was representing a full circle of 360 degrees. Now, sometimes we need to get greater precision for many of these geometric problems, and I, in college, took a class in surveying, and it was very critical that we didn't always round to the nearest degree. We'd have to go to fractions of degrees. And so we're going to find out ways to measure these fractions of degrees. So say, for example, you have 45.23 degrees. We actually break down each degree into degrees, and then we call them minutes and seconds. So if you have 1 degree can be broken down into 60 minutes, and then each minute, so a minute is 1 apostrophe there, can be broken down into 60 seconds. So it's very similar to our time. Degrees, minutes, seconds, hours, minutes, seconds, similar concepts, but it's just a very precise way to measure down those degrees. And so let's take a look, and if I've got 45.23 degrees and I want to get that into degrees, minutes, and then seconds. So again, that's the notation there. Then what I'm going to do is I'm going to say, well, I already know I've got 45 full degrees. So this is going to be 45 degrees. But then I've got to take the decimal portion, the 0.23, and I got to break it down into minutes and seconds, because those are going to be that's going to be my fraction portion. So I'm going to take 0.23, and I'll just say degrees, and times it by, and remember that 1 degree is 60 minutes. So our degrees will cancel, and we'll get 0.23 times 60, which is 13.8, and this is in minutes, or again, you can just use the apostrophe. So we're going to have 45 degrees. Then the next, I'm going to take the whole portion there, 13 minutes. And then I'm going to take the 0.8 from this decimal here. So this is 0.8. Oops, not degrees. We already did that. That's 0.8 minutes. Times that by, for every 1 minute, we have 60 seconds. So that would be 8 times 60. Excuse me, 0.8 times 60, which is 48 seconds. So this will be 45 degrees, 13 minutes, 48 seconds is equivalent to 45.23 degrees. And it's just a way to get very precise on your angles and some things you're doing, especially in construction, in measurements, in space and things. I mean, we got to get very, very accurate. So that's why we go degrees, minutes, and seconds. Okay, now, what if you have something like 30 minutes, or excuse me, 30 degrees, 33 minutes, 31 seconds? How would you write that as a decimal? Then you're going to take your 30 degrees plus, and now I have 30 minutes, and remember that 60 minutes is 1 degree. And then you're going to say plus 31 seconds. And then I need to go from seconds to degrees. So if you think about it, there are 3,600. So that's 3,600. I need to write that a little bit better. There's 3,600 seconds in every hour. So 3,600 seconds in every 1 degree. So this becomes, and you cancel out here, you cancel out here, so you get 30 plus 30 times 1 over 60 plus 31 times 1 over 3,600. And if you multiply that out and then you add these things together, then you'll get 30.56 degrees. Okay, so that's how you would go from degrees to degrees, minutes, and seconds, or from degrees, minutes, and seconds back to degrees. And again, it's just another way of writing degrees that are in a fraction form in a much more precise manner. So just remember, you can take a degree, you can break that 1 degree down into 60 little minutes. Then each of those little minutes can be expanded into seconds. So seconds are very, very, they're 1/3600th of a degree. So minutes are very minute, very small, but again, they're very helpful when we are trying to get very precise calculations done. So that's how you convert from into degrees and minutes and seconds. And so hopefully that helps out in that idea. We're going to talk about angular size and distance in our next video, but if you have any questions on this one, please do not hesitate to let me know.